Let's do this. Let's do this. Hi, welcome to this session about testing in production as part of stackconf Virtual 2020. I hope you're having a good day, and if all goes well, you enjoy the presentation and learn something new today. Right, I won't bore you with details about my life. All I want to say is that my name is Jorge, and I'm an engineer. I work on autonomous indoor navigations for UAVs. That was my passion, but then got dragged to the cloud space. I'm currently working at Dyson as a software engineer, just a vacuum cleaner company, and no, I don't have any spare discount codes. Now, every presentation, I like to start with a small poll time, and I'll ask the public to raise your hands, but given this is a virtual conference, I won't see you raising your hands, so please use the comment section, and then after the slides, follow me on Twitter and like and subscribe. Now, raise your hands. I want you to raise your hands if you are having a good day or you often forget to squash before merge. Now, if you know what testing is, if you know about the testing pyramid and any other way of classifying different testing levels, if you have a production environment, probably you do, and if you're testing your services in production, I hope you are, and also raise your hands or put it in the comment section if you prefer spaces to tabs. Now, this talk is going to be mostly answer to frequent asked questions around the end-to-end test and the different levels of testing for production systems. It's not going to be too technical, and it's based on my experience, on the experience I acquired while working at Dyson for the past 2.5 years. The main takeaways for this session I want you to understand or to learn is why do you need test in production? I'm going to explain that to a certain level. What is the right level of testing against production systems? What is the kind of testing that's appropriate? Then I'm going to talk a bit about how to build end-to-end tests for a microservice API-based architecture, and then finally how to fight dragons. So allons-y. Why do you need testing in production? Well, that's a good question, but first we need to answer, what do you mean by testing in production? Let's put this. To guarantee that your Lambda, your service, or your application continues to work consistently after the release or the deployment. This means that you need to have some kind of automatic scheduled test to guarantee that your application still works as expected after being deployed to production, because the users are being constantly using it. And you might say, well, but I have the best real-time health dashboard that will notify me if something goes wrong, and I'll know, and then I'll just fix it. What's the problem with that? Well, are you sure you are really protected against bugs in production? Let me put this example. So imagine a function, right? A serverless service that only purpose is to return the current date. So it has a function that's called getDate, and whenever you perform a get action on it, it returns the current date. It's a pretty simple and pretty easy to use function. It has been unit tested. We also have integration tests, and it has also been manually tested several times, and it always returned the current date, right? So what's the problem? Well, until the year 2038. So what happens on the year 2038? We have what's called the Y2K38, which is similar to the problem of Y2K that happened back in the 2000. So most programs or most computers store the dates, the current date, as a signed 32-bit integer. You can see on the screen all that many zeros. Those are 32 zeros. This is the starting date. So it's the 1st of January 1970 at the 000000 in UTC, of course. So it's plus 0 seconds. This is the beginning of the Unix time. Now, what's today? Today looks like this. Today is the 17th of June of 2020. It's plus 159.23.79.000 seconds, and it looks like that in the registry. Now, if we go ahead in time, we go to the future, and then we stop at the moment this registry is all ones except the first digit. What date is that one? So that date is going to be the 19th of January 2038 at 3 a.m. 14 minutes 7 seconds. That moment in the year 2038, all that registry is going to be 1. It's going to have the value of 1 in binary, except the first digit, which is 0. What happens the next second? So this is, remember, this is the number of seconds since 1970. So if we add 1 second to this registry, we get this number, right? What's wrong with it? Well, if you again remember, I said that this is a 32-bit sign integer. So the first digit is the sign of the number. So this represents minus 214,748,3648 seconds, which correspond to the date, the 13th of December 1901. Like, it was a Friday, like 100 years ago. It's one day after Guillermo Marconi received the first transatlantic radio signal from Cornwall, England to Newfoundland in Canada. So you're going to have this problem. No matter how many tests you perform before the release, the get date function is always going to return the current date up to this point. At this point, the function breaks, and it's going to break for all your user base. So the bug will only show when in production, as most bugs, to be honest. So yeah, tick-tack, tick-tack. But don't worry, it's not going to be the end of the world. Stop running all over your apartment screaming. We already know this, and our systems and programs are already prepared and patched by then. So now put this example, extrapolate it to a real service. So one of your stateful services become inconsistent and start failing for all customers. By the time you start looking at the problem, a big part of your customer base is already affected and your customer line is on fire. And your customer might be saying things like, I cannot log in, or I cannot change my profile picture, or cannot order a chocolate milkshake to take away. At this moment in time, you consider making this decision. You start comparing the two different things, testing in production and not testing in production. So if you don't test in production, you have these real angry paying customers calling you because what they paid for is not working. And then you fix the bug. Yeah, that's all right, but you already have all your customers behind you telling you that it didn't work when they need it. Now compare that to having an automated process acting as a real user that performs all the actions that a real user is supposed to perform, but in an automated way, and it's gonna be so fast that you're gonna be notified even before any actual real customer can stumble upon the bug. Now, are you convinced already or not yet? Well, let's compare the speed of the two methods, right? So if we have the first method, no test in production, all your customers are running behind you and telling you that your application is not working, whereas if you use this testing in production approach, you will fail fast, you will notify your engineers fast, and you'll fix fast. So the bug might be fixed even before reaching your user base. Now, if we compare the losses, you're losing time, money, and also losing, you are spending a lot of resources on support because all your customers are going to be calling the support line telling you that it's not working, and that's time and that's money. But if you have this automated process, you don't need to have that many support lines, and it will find the bug faster than a user would. And the last thing is reputation. So if a lot of users are experiencing the same error, then the reputation of your company, or the reputation for your service, is going to be pretty low, and users are going to be a bit angry at you. But if you have this automated process and you're testing in production constantly, the amount of users that will get hit by this bug will be much significant less. Are you convinced already? Now you should. But let's talk a bit more about what's the right level for testing in production, right? So most of you have already seen the testing pyramid, it might look like this one, or like this one, or like this one, or like this one, ad infinitum, right? So let's take this one, for example, and let's talk a bit about it. So at the bottom, you have the unit test, then we have the integration test, and finally, we have the end-to-end test. Of course, the more at the bottom we are, the smaller are the size of the test, but also the more up we go, the more expensive is to run the test, is to write them, is to run them in terms of time, in terms of resources. It's more complicated, right? But they give more value, more user value. They deliver more user value. So if we look at the middle one, which are the integration tests, this would test the minimum unit after the deployment. So when you deploy a service, you do some kind of integration test against that service to see if that service is working fine or not. You're testing the service as a black box, and you only interface with that service. And the next level is to have the end-to-end test. The end-to-end tests are looking at all the services at the time, as a real user would do. So it's the minimum unit a user sees, not a minimum unit after the deployment, but what the user actually is interacting with. So it always refers to a user action, a user intent, or what we call a user journey. So for example, changing your profile picture is a user journey because it will involve it might involve several microservices. So you want to test all the services as a whole and not the single services separated. Now, let's put some examples, right? So now that I'm talking about the end-to-end test and saying how important are they, let's talk at how we implemented this or how we approached this at Dyson, the company I'm currently working for. So at Dyson, at the moment, we have more than 1 million connected devices like robots, like vacuum cleaners, like air purifiers. They are connected to the cloud, right? And we need to interact with them, and the user is also interacting and sending commands to the machine to say, hey, could you please start a clean? Hey, Dyson, could you tell me what's the air quality at my bedroom is, and that kind of stuff. And we are approaching 2 million devices now. We have users all over the world, and all the users are performing the actions, as for example, renaming their robot or telling the robot to clean. But how can we define that end-to-end test, that example? So we could define an end-to-end test like a mix or a batch of single actions or very specific actions that in the end describe an end-to-end user journey and describe a specific scenario. So to put as an example, we could have this: given an existing user with this configuration, when the user logs in, the user then changes the robot name to RobotMop 9000, then the robot name has changed to RobotMop 9000. That's it. As simple as that. That's a scenario. That's a user journey from end to end. So the user starts, you have a user, you have a configuration, and the end is the robot name has changed to the name that the user has set in the middle of the test. And this is testing several services in the middle. This is testing the login service, this is testing the microservice for changing the robot name, it's testing also that the robot is receiving the correct commands, and much more. Now, in terms of the architecture, how would you create, or how would you define this level, these individual steps? Because you'll need a real user, you'll need a real machine, and you'll need a real cloud to see all the interactions going around. As you can see here, you have the users which talk to the cloud through the smartphone app, and we also have the machine, in this case a robot. What happens is that we can write a service that interacts with the cloud, but also inside has a mock, or it's emulating what the users or what the smartphone app or what the robot will do. And it's just a single app, it's all software, so it's going to be talking to the cloud, and all we care about is what's happening in the cloud, and we are receiving, and that we are receiving the correct responses, and we are acting with the correct commands and answering with the correct data. So this is how you define it. And then if you want to know a bit more about how to implement this in a real world scenario, we could use a library that's called cuckoo.js. The Cuckoo Bird library is defining this behavior driven test where you tell the test what are you doing and what you expect, and you don't care what's happening inside. As we explained, the user login, the user changed the robot name, and then the robot name gets changed. That's how Cuckoo Bird works. So it's a combination of this library, Cuckoo.js, the request and assert library, because we are working with microservices, APIs. So we have, as I said, lots of single steps defining the calls to the different APIs and doing data transformations to emulate or simulate the users and the machines. And then we group them together to form a user journey or a scenario. These are some examples of scenarios you could define. Given an existing user with this configuration, when the user logs in and the user changes the robot name to RobotMop 9000, then the robot name has changed to RobotMop 9000. Given a 16 user with this configuration, when the user logs in and the user schedules a clean, then the robot starts to clean within 10 seconds. And another one will be given an existing user, the user logs in, the user stops the clean, then the robot returns to the base within 10 seconds. So those are examples. But these are the end-to-end tests. They sound cool, they are cool, but they have its own downsides. Because you are testing in production, you're gonna have some issues. As this is production and all your customer base or your users are also using the same system in production, if your tests are too close to the real users and the real actions, you might have side effect where your tests are affecting your platform and are affecting, for example, the backend. So let's say you run a lot of end-to-end tests because you want to know how your service is performing, and you do it, I don't know, let's say you do it every minute, you are testing your services like a user would do, right? Maybe you are testing them so hard that that your service are affected by the load you're putting on them, and this reflects in a slowdown for your users. So your service is actually slower than before just because you are putting more load on it. But it's not real user load, it's your own end-to-end test. But as you are doing against production, there's no other way. Other examples are, for example, if you have a database, for example, let's say you have a DynamoDB, which is a database in AWS, and imagine you're making a lot of requests. You have a capacity when you spin up a new database, a new DynamoDB table, you set a specific capacity to it because capacity is not infinite. But then if you are testing with your end-to-end tests in real time in the production system, you might reach those limits, and then your DynamoDB, your database, might start throttling, and that will affect the users. But they haven't done anything wrong. It's just your end-to-end test fiddling with the production system, right? So one solution to it could be to space this end-to-end test. So instead of running them every minute, you run them every 15 minutes or every 20 minutes. The more often you run them, the faster you will notice an issue. But it also, if you run them a lot more often, you get more noise and it's slowing down your production system. So you need to strike a balance between how many times an hour you want to run the end-to-end test, so that you are not having that many side effects to it. It is also true that by using this virtualized user, it's also interact with your login service or with whatever your login backend is, and you'll need to use these virtual users with their own configuration. So they need to have their own email, their own history of actions, their own configuration. These users should be set up as real users, but with fake email accounts or fake configuration. but it should, as I said, it should imitate the real user behavior and a real user configuration. Now, there's another problem when you're running this end-to-end test in production. As you're performing as a real user, you're faking the system, telling it that you're a real user. You might also be skewing your statistics, your metrics. So every request to an API, it comes from the end-to-end test, or it comes from a real user. It will add a count to the number of requests, and it will add latency to your registries, and it will add everything to any metric, any statistic you want to take out from your production systems. Any problem? So, as I said, yeah, all the metrics, API usage, error count, etc., and also the logs in production. Sometimes inspecting the logs is useful to find out bugs and to find out what problems are some users having with your system. But if you have this end-to-end test, they add a lot of noise to the logs, and you'll get mixed logs, and it's going to be difficult to differentiate between what the logs are for real users and what are the logs for your end-to-end test. So it's getting complicated now, right? Well, there's some solutions to it. If you're thinking in terms of web APIs and in terms of HTTP requests, you can create a correlation ID. So you can put in the HTTP header a correlation ID header with a specific UID, and then you can filter out those UIDs from your logs and from your metrics. You can also change the user agent, which is another HTTP header. You can set to a specific string saying, I don't know, my testing app version 000, so you can then filter them out, or you can use custom HTTP headers. What else? Well, we have more problems or more things to take into account when you run end-to-end tests. Running tests in production is great, right? But all the fake data they generate, what do we do with that? Well, it's going to fill our database, it's going to fill our buckets, it's going to fill our storage. It's just stress, right? So we need to automatically clean as much testing items as possible after each test. Basically, the main objective is to leave the system as you found it. So the end-to-end tests, of course, they're going to affect production because you're running them against production, but you should leave production as you found it and avoid cluttering it with testing user, with testing artifacts, because in the long term, as you run this end-to-end test more and more often, your systems are going to be clogged up with all these fake users that you don't really care about. So yeah, cleaning up is very important. It also helps because if you clean after every test, it also helps to start the next test from a clean state, avoiding false negatives and avoiding cluttering your production databases. It also, when you clean, it avoids exhausting other limited resources like space, and making real data much more difficult to retrieve and search if you don't clean up. Now, this concept about end-to-end tests and how to implement that is very interesting, but you might have a lot of questions now. I'm going to try to answer them in this presentation, and if still after the presentation you have more questions, you can write them on the comment sections. I don't know, it's going to be on my left or on my right, but yeah, please type them there and I'll be watching. So for the new questions, you might say, can your end-to-end test pass and you still have problems? Yes, you can. Yes, you can still have problems, but the thing is that the closer you make your end-to-end test to a real user journey, to a real user interaction, the closer it gets to represent the state of your services and the state of your cloud or your microservices, right? So if you do exactly what users are doing, then yes, if an end-to-end test fails, then you have problems. If an end-to-end test passes, you don't have problems, because an end-to-end test is really like a user performing the action. So if the end-to-end test can perform the action, probably the user can too, right? Now there's another question. By the nature, end-to-end tests span multiple services and teams. Who is responsible for writing them, or how do teams collaborate to write them? Well, here at Dyson, we have a team responsible for the main framework and for defining the little steps that you saw earlier. So for example, user logs in, that's a little step, a small step, a predefined step that everyone could use and to build up on top of that. So yeah, there's a team responsible for the main framework, and then each team will try to write their tests based on those single actions. So the single action, remember, you put a lot of single actions together and get a scenario. So that's how we collaborate within Dyson in terms of end-to-end tests. But all the teams are responsible for maintaining those, because this is how the Dyson Cloud, or this is how the compendium of all of our services is behaving against the user. So all teams should be concerned about it. Another question you might have is, how do end-to-end tests compare to dark or canary deployment? Do you need both? Well, obviously there are cons and pros for each of them. Definitely you should be using canary deployments, but you could also run the end-to-end test to make sure your services are ready to be deployed to production. So for example, you can run these end-to-end tests even though they are designed to be run in production systems. You can run them in your staging environment or in your development environment to verify, to assert that the new version of your service is not breaking any user journey, so that when you deploy to production, you're still going to run the end-to-end test in production, but you are certain that the user journeys are still there and are still working. So do you need both? Yes. And how to avoid end-to-end tests becoming fragile. So to have these flickering states where one end-to-end test is successful, but the next one is failing just because the previous one has made an action and it's made the system inconsistent or whatever. Basically, by cleaning after you and by cleaning after the test, you avoid them getting fragile and getting all those false negatives. And yeah, as a recap for the whole presentation, testing in production is good and necessary. I've explained an example of testing microservices, APIs with HTTP calls, but you can apply this whole concept of testing in production using end-to-end tests to any kind of interface. For example, you could do end-to-end tests, UI end-to-end tests using the browser, using Selenium, using Puppeteer, or any other kind of headless browser, as long as you test what a real user is going to do end-to-end. It's a user journey. You don't need to click on all the buttons. For example, in the UI, you don't need to click on every single link or every single button. You need to represent, your test is a model for what a real user will do. If that test passes, then the user should be able to perform that action too. You need to think as a user and act as a user. This is the same that I've described before. Cucumber.js is a good start if you want to start writing this end-to-end test using the Node.js platform. You also need to think about your system capacity, not to overload your system running end-to-end tests every minute if your system is not capable to cope with that load. Also, you need to mark your test intents to differentiate them from real user interactions using the correlation IDs or using custom HTTP headers, basically, so you can filter them out. Also, clear your test data and reset all the connection and status after each test, so clean after yourself. That's basically it. If you have any more questions, as I cannot answer them right now, leave, but you can use the comment section and I'll be there answering all your questions. Please follow me on Twitter and like and subscribe. That's all, folks. And you, are you brave enough to taste in production? Thank you.